This is a paper by James Chen. It's a TMUA paper. It's a mix of paper one and paper two questions. The 20 of them. It's a really nice paper. It's been really well written, and so yeah, thank you to James for writing it. It's in the description below in case you want the entire thing. We start off very gentle, perpendicular bisector, right? So we just draw it -3, 5 and -1, 9. It's going this way, so that's a positive gradient. Um, I actually worked out the midpoint, although I later realized it was only asking me for the gradient. So you don't need this. It just goes across 2 and up 4. So this is gradient 2, and then therefore the perpendicular is gradient -1/2 because it's going this way. So we just select A. And yeah, we move on. And cool. So how many distinct solutions does this have? Well, it's just a quadratic, right? Because this is x to the 4 squared, and this is x to the 4. So therefore, we can complete the square on this. We notice it doesn't factorize, so completing the square is probably the most efficient thing to do. You don't have to make the substitution at any point. You can just roll with the thing as it is if you're comfortable, and it makes it a bit faster if you do that. When we solve this, we get this. Now, 1 minus root 5 is negative, so that can't be x to the power 4, because x to the power 4 is positive by definition. However, 1 plus root 5, when you take the fourth root, will be a plus or minus. So it will be plus or minus the fourth root of 1 plus root 5. So therefore, there'll be 2 solutions in total to that. So pi squared is roughly equal to g, sure. So we're being engineers for this question. Log pi, if we start with maybe log pi, that's going to be obviously a half log pi squared because this 2 and this half will cancel based on log laws. Pi squared, of course, is just g. So that makes a half log g, but then, of course, this half can be instead rooting this g. And so we'll end up with b being our roughly equivalent thing. Perimeter is 2 pi r and area is pi r squared. If you want the perimeter, say, to be bigger than the area, I mean, some of these are less than, some of them bigger than, then pi is positive, so we're allowed to divide by that. R is positive because it's a radius, so we're allowed to divide by that. So therefore, 2 ends up being bigger than r. So we want r to be less than 2 for the perimeter to be bigger than the area. So let's look carefully if there are any conditions that say that. So perimeter less than area is down here. R less than 2, it's got to be bigger than 0 because it's a length. So I think, therefore, think this one. Yeah, sorry, perimeter bigger than area. This one down here. G will therefore be the answer. It's necessary and sufficient, by the way, because all I did was very basic algebra. And algebra is basically a necessary and sufficient thing. So yeah, cool, done. This integrates to x squared minus 3x between a and 0. We put in the a and the 0. That's got to be equal to -2. And yeah, I mean, we solve TMUA thing should factorize. It does, and we get a as 1 and a as 2. And we're pretty much done. Question 6, an incredible question. According to One Direction, and now the only thing firstly I know about One Direction is that they contained the singer Harry Styles. So here's a picture of Harry Styles. So may as well have him for moral support. Now it says here, they think you are beautiful if and only if you do not know you are beautiful. Now I looked up the lyric to this song because I do vaguely remember this song. And it says right here, you don't know, uh-oh. You don't know you're beautiful, uh-oh. That's what makes you beautiful. Now I don't think that's an if and only if statement here. Not that we're going to deal with this if this isn't anything to do with the question, but I would argue that One Direction is simply saying that the person they're singing about happens to be beautiful because he or she doesn't know they're beautiful. That's not, but they're not saying that's the only way that they could be beautiful, which is what if and only if means. So it doesn't matter. It's irrelevant. I might be wrong, but I'm going to contest that this is what One Direction have said. In any case, we'll continue the question with this statement here. They also said that if you flip your hair, One Direction will be overwhelmed. So let's bring up that lyric. The way that you flip your hair gets me overwhelmed. That cut and dry, that's fine. They're saying if you flip a hair, they'll feel overwhelmed. So I agree completely with that. So cool. Okay, excellent. Let's actually do the question then. If One Direction has felt overwhelmed, you have flipped your hair. Not true. This isn't saying that there aren't other circumstances in which they'll feel overwhelmed. They're just saying they will if you flip your hair. So, I mean, they might have felt overwhelmed when Zayn left, for example. So A is not true. Part B is in direct contradiction to the if and only if, because if you do not know you are beautiful, according to One Direction, you must be beautiful. It's if and only if. So it is possible that you're not beautiful. That's not true. According to One Direction, that's got to be gone. It is not possible for you to be beautiful. I mean, what, you could be Chris Hemsworth, obviously. So I don't understand what that has any relevance to the question at all. If One Direction has never felt overwhelmed, you have not flipped your hair. Now, this sounds pretty likely because it says they'll feel overwhelmed the second you flip your hair. So therefore, if they've never felt overwhelmed, you must never have flipped your hair. So I think D is the true statement. Just to wipe E and F off, just to make sure. The problem with E is the or bit, then the and bit, right? Like if you flipped your hair, or you do not know you're beautiful. Okay, let's just say you flipped your hair, but not the other thing. Well, then One Direction has felt overwhelmed, but you might not necessarily be beautiful because you might think that you are. So that is the or then the and, I think, that makes that go wrong. And then F, it's possible for you not to feel overwhelmed by One Direction, but not beautiful. Well, those two things are part of two different statements, right? The overwhelmed thing is to do with flipping the hair, but the beautiful thing is to do with not knowing you're beautiful. So those two things are irrelevant to each other. So therefore, E and F, I think, are therefore not true, and we're pretty happy with D, I think. And yeah, moving on, I think. Question 7. So I mean, this you can factorize this and do a bit of cancelling and end up here, and then think, well, when infinity goes in, it's just infinity plus 2 over infinity plus 1, which is basically 1. You can also just look at this and go, well, okay, these are both cubics with leading term x cubed. None of the other terms matter when x goes into infinity, so x cubed over x cubed is just 1, right? You can just do that. That's fine. You probably haven't seen that much to do with limits, but that's just something you can do. This is tangent to this. Well, therefore they intersect, right? If they're tangent, they intersect, and specifically they intersect one time. So if we just set x equal to this and then solve, this should have one. The discriminant of this should be 1, right? Because the tangent just touches the curve. So we can test the discriminant, which is this. So a is 4. And when we plug in a is 4, we get 4x squared plus 4x plus 1 equals 0, which therefore means that obviously factorizes to 2x plus 1 all squared, which means x is minus a half, which is option A. There are many other ways to do that question, but that's probably the fastest, I would guess. Here, again, we've said this so many times during TMUA papers, being good at these indices. This is 10 times 10 to the r because, oh, sorry, dot means times. Sometimes I do that when I'm not thinking. So 10 to the 1 times 10 to the r, you add the powers, you get this. Now, of course, this is just 1/10. It kind of can factorize out, but what I'm actually going to do is factorize out a 1/100th. And then, of course, 300 over 100 is 3, so that works. 10 over 100 is over 10, so that works. And 4 over 100, which is already here, can just be taken out. So this is fine. Now these things can add together. I haven't bothered to put the limits up here because I just couldn't be bothered to type them. But here, obviously, the 314 can come out. And now this is just a geometric series. No, it's just 1 over 10 to the power 0 first, which is 1, plus 1 over 10 to the power 1, which is a tenth, plus 1 over 10 to the 2, which is a hundredth. So its first time is just 1, and the r is just 1 over 10. So the sum to infinity, which is what this is just a over 1 mass r, which is 1 over 9 tenths, which is 10 ninths. So the answer will be this times 10 ninths. Now, obviously, these cancel to make over 10, so the whole thing would be 314 over 90, but you could divide both those by 100 to end up with that answer there, I think, would be acceptable. I don't know why the answers were written like that. Anyway, 8 people, all of these people, wearing t-shirts and spelling this. Now, the key here is understanding that person P and R and O can't go anywhere. Like they're stuck in place, right? The E's and the S's can move around. So you've got one person E, so this is Emily, and E2 is Ethan. And likewise with the S's, E1 might be Sedant, and E2 might be Simon, and S3 might be Sabrina. They can move, right? The E's can swap. So there's 2 options for the E's to go, right? They can just swap over. The S's, there are 3 of them. So there's 3 people you could put here. There's 2 people left you could put there. And then the last one has to go there. So it's 3 factorial, right? So the total number of ways of doing this is technically 2 factorial for the E's and then times 3 factorial for the S's, which is, of course, 12 because it's 2 times 6 to make 12 in total. This function looks like this. Now, firstly, this inverse function can just be swapped to the other side to make a regular function on the left. So we make this. And now I think the best way of doing this is literally just to test these options going down. So f of x equals x just means f of this equals this. So we'll just put that there. And of course, f of a is just a, and f of b is just b, and so on. Now, this is not necessarily the same thing because this is a geometric mean and this is an arithmetic mean. They're not necessarily equal. So I don't think a is a function that does satisfy it all the time. B, so we're replacing x with x squared according to the function. Well, this squared is just the square root rather than the fourth root. And then f of a becomes a squared and f of b becomes b squared and so on. Again, these things are not necessarily the same, I don't think, so we'll move on. C looks pretty bad, but okay. We're going to replace x with log base 2025 of the input this here. Now this is a quarter, or this is power a quarter, right? But with a log, power a quarter can go at the front and it becomes 1/4, which immediately looks good because of this quarter can of course also be a quarter. But then of course log of stuff multiplying is the same as log of all the things individually adding, which is over here anyway. So therefore C satisfies the rule and we can stop looking. I think we're good. I think anyone who's done maths has seen this proof here. So we should be able to just say 5 and move on. But anyway, just to explain, here is the problem. The factorizing is fine, but it's getting to this next line that's the problem. Because A equals B, that means A minus B is 0. So when you cancel those two things out, you're dividing by 0. When we were doing the perimeter area question, I talked about the fact that pi and r couldn't be 0 or less than, so therefore are allowed to do things. If they're 0, you're not allowed to do things with them. You're not allowed to cancel them out, because like 7 times 0 equals 2 times 0, but that doesn't make 7 equal to 2. So we can't cancel those things out. We're dividing by 0, so therefore this line is the first line that's actually wrong. Question 13, then, numbers a and b. A is bigger than b. The function is defined over positive real x, and it's always increasing or always decreasing. So, okay, that means the function looks a bit like this. It's only defined over here. You have an a bigger than a b, so that's over here somewhere. And which of these conditions is necessary for f of a to be less than f of b? So f of a may be here, f of b over here, and we're less than this way. So this is the general setup. Now, which of these conditions is sufficient but not necessary? Well, both of these conditions are basically the same thing, right? I know the textbook talks about decreasing function as less than or equal to 0, I guess. Although it actually says you're allowed either one. But the thing is, you're already told that this particular function is always increasing or decreasing, so you're not being told anything here other than the fact that, oh yeah, it's the decreasing one. But you knew it had to be the decreasing one anyway for this picture to work. So this is, I think, necessary and sufficient, not sufficient but not necessary. This here is talking about a specific function, which sounds great because a specific function could well be sufficient, but not necessary because, of course, there could be other functions that do it. Now, log to base c of x, if c is between 0 and 1, actually looks a bit like this. And the reason it looks like this is because of you can do some fancy log law work if you want to, where you replace this base with a base that's more normal, and then you'll see that it ends up just essentially flipping in the x-axis. Because, of course, a regular log with a c bigger than 1 looks like the other way up, right, like this. But, of course, this is the one that we want because it's decreasing. So that there is sufficient, but probably not necessary. Question 14, then. I promised to do at least 5 step 1s, 3 step 2s, and at least 1 step 3 next week. If I break a promise, which of the following must be true? Now, A and C I have problems with immediately because of this word and in both of them, as opposed to the or in B and D. Now, A says fewer than 5 step 1s, 3 step 2s, and no step 3s. But it says and, right? Like, to break this promise, you could do 5, 3, and 0. You only need to break one of these 3 things to break the promise, not all 3 of them. So A and C I'm just going to get rid of because I don't think that's necessary at all. Like, you can just break 1 or 2 of the rules, and you don't have to break all 3 at the same time. Now, we're just deciding between B and D. Now, D says I'll have done fewer than 4 step 1s, which is 3 or less. Fewer than 2 step 2s, which is 1 or less, and no step 3s. But again, if you did, you could have broken the promise by doing 4 step 1s, 2 step 2s, and 0 step 3s. But this is claiming, so this statement does not have to be true because this is saying you've done fewer than that, right? So if you did 4, 2, and 0, you've done more than this, but you've still broken the promise. So D can't work out, so it must therefore be B just by process of elimination. Question 15 then. So the best way to do this, I think, is to look for the roots because all of these have different or claiming different things about the roots. Doesn't seem like it'd be too hard to find the roots here. So set it equal to 0, square root of 0 is still 0. So we're looking for sine of x to be 3/4. Now, I don't know exactly where that is, but it's about 0.75, right? And I know root 3 over 2 is about 0.8 or something close to it. So 3/4 is probably something around 1 and 2.1, I said. On this basis, I said what was going on in my head was sine x equals root 3 over 2, which is, I know, somewhere near 3/4. I know that's pi over 3. And pi over 3 is a bit bigger than 1. So I'm looking to be a bit less than that. So I just said 1. And then, of course, I'm going backwards 1 from pi to find the other solution. So about 2.1. Again, I'm going to accept anything from quite far away from that. But I'm looking here, and the only one with 1 and 2.1 roughly is here. Now, this seems okay, maybe, if I'd missed some solutions, but I don't see how I have. The next one's here, would be some negatives if you're going backwards, or some positives when you're going up 2 pi, but that's miles away. So I think C is the only reasonable thing here. Question 16 then, the Backstreet Boys are asked if they want it that way. Here's all their responses. They're lying if they don't want it that way. Which of these must be false then? So it's not necessary that at least one Backstreet Boy wants it that way. So, okay, can we find a correct setup where 0 Backstreet Boys want it that way? Well, okay, if Backstreet Boy A doesn't want it that way, he's lying, and we don't have one of them. But the same for B and D and C and E, right? They could all just be lying because they all don't want it that way, and that's all fine, right? They're all just lying. It's all good. So I think this is a true statement. It's not necessary that at least one Backstreet Boy wants it that way because it's completely fine if 0 of them do. So A is true. B, it's only possible that Backstreet Boy A wants it that way. Well, immediately that's false because we've just found that if all 5 Backstreet Boys don't want it that way, that's fine, right? So this is completely, definitely false. So B we can underline before even, I mean, we can just now move on. Just to clarify though, C, it's not possible that 2 or more of the Backstreet Boys want it that way, and D, it may be possible that Backstreet Boy B wants it that way. Both these are kind of similar, right? Like, basically, if you want more than one of them to want it that way, then Backstreet Boy A must be lying because he's claiming only one of them does, which means he doesn't want it that way. But then you kind of end up with these contradictions because suddenly B is claiming 2 of them want it that way, and the others are claiming even more of them do. But you've already got A not wanting it that way, so there's no way to make it work because they're all claiming. Essentially, all of these people kind of require A to want it that way for their statements to be okay because they're claiming more and more people want it that way. So C and D, I don't think is going to be very likely at all. But we've already said that B is definitely fine, so we can move on. Arithmetic sequences go A plus R, sorry, or A plus D, A plus 2D, A plus 3D. Geometrics go A R squared, and so on. But the first terms aren't necessarily the same. So we're going to have to write these sequences out with A1 being the first term and B1 being the first over here. Now, the second term, which is A1 plus D, equals the third term, which is B1 R squared. And the fourth term, which is A1 plus 3D, equals BR, or B1R, I should say. And now look at all of our answers here. They obviously don't want me to have a little d in it because I made that up. So I'm going to times this by 3 and then take them away. And we end up with this. And this is pretty much immediately answer A. Just divide by 2 and factorize out the 3R from the top. Or sorry, the B1R from the top. And you end up, I think, with A pretty much immediately. Question 18 is a fun one. So we substitute in 0.2 and 0.3 and we get this. Now, the key here is 0.3 plus 3 lots of 0.2 is 0.9, which is this one. And the next one is 0.3 plus 4 lots of 0.2, which is 1.1. And the next one's also going to be bigger than 1, and then bigger than 1, bigger than 1, and so on. So what's going to happen here? Because you evaluate powers from the top down, because all of these are bigger than 1, eventually, let's just go into the future. There should be dot dot dots here, obviously. When you go into the future, it's going to be a really big number to the power of a really big number, which is a really, really big number. And it's just going to get bigger and bigger and bigger and bigger and bigger and bigger as you go down. So basically, by the time you've evaluated down to here, you're at infinity. And then you're doing a 0.9 to the power of infinity, but 0.9 is less than 1. So when you power that up a load of times, you just get to 0. And you will be at 0, essentially. And then, of course, something to the power of 0 is 1. So now we're doing 0.3 plus 0.2 to the power of 1. But that's 0.5. And then 0.3 to the power of 0.5 is just root 0.3 by definition. And so we're left with answer C. Question 19, I literally just didn't know how to do this question. There are lots of ways there are some incredibly bad ways you could do this by setting up f of x equals x to the power 5 plus ax4 plus bx3 plus and so on, and then just sorting out a 5-dimensional simultaneous equation. I couldn't be bothered. I knew there must be some shortcut, so I looked at the answer book for the shortcut, and yeah, it's quite an ingenious one. What you claim is that this is the function that you want, right? You just want the function that goes 6 minus x because of these numbers, right? 6 minus 1 is 5, 6 minus 2 is 4, and so on. Now, the problem with this, of course, is that it's not a degree 5 polynomial. So we're not allowed it. But what we can do is we can create a degree 5 polynomial from this, whereby all of the rest of it that's going to be the degree 5 bit is just 0 at all of these evaluations, so that all of these evaluations still hold. And how do we do that? Well, we just add this, right? We just add this thing. because if you evaluated this at 1, all of this goes away, and the answer is still 6 minus 1 for 5. And if you evaluate at 2, all of this goes away because of this, and the answer is still 6 minus 2 is 4, and so on up to 5. But this is a degree 5 polynomial. And the fact that the 5 coefficient is 1 means that k just has to be 1, so we're left with this, and we can just evaluate this at 6, and we just get 5 times 4 and so on, which is 120. It's a good question, but yeah, very, very unusual. I could see TMUA asking it, though. I could certainly see TMUA pulling out something like that, because it is very ingenious to try and force that function to work like this. So yeah, it's a good question. Anyway, question 20, distinct positive pairs that make this. I think I've done this question before, to be honest, somewhere. I don't know where. But anyway, you pull the b squared over, and 20, I mean, if you did the senior math challenge, you should know this stuff here, to be honest. But yeah, it's 45 squared, which is this. Now, you can factorize this as a difference of squares, and then you're just looking for something times something to equal this thing here. Now, the ways to know how many ways you can do something times something to equal something else is to look for the prime factorization of the thing, which is good because I've already got that. And the number of factors that this number has is this number plus 1 times this number plus 1. Somewhere there's a video on this channel, and I'm sure there are better videos on lots of other channels explaining how to find the number of factors of any number. Just YouTube that and you'll find this explanation. But it's just this number plus 1 times this number plus 1, just a nice little trick. So the number of total factors of this number, which of course is 2025, is 5 times 3, which is 15. Now, I'll put that there. Just to explain what's going on over here, I don't know why I did this first, but like, for example, one of the ways you could get this to work was to make this a 3, and this everything else, which will be a 3 times 3 times 5 squared. So that's one way of doing it. Now, I do need to check that these will all make distinct positive integer pairs, but because this is odd, and when you add them together to get rid of the b's, it will be an odd plus an odd. When I divide that by 2, it's going to be fine, right? And likewise, it doesn't matter how you split these pairs up. Like if you take 2 3s instead, it's still going to be odd plus odd, then divided by 2. So everything's still going to be fine. So I don't think I need to worry about not making integers by timesing these. I think we're going to be fine. So, okay, we don't need to worry about that. We've got 15 in total, 15 factors. But that, of course, they come in pairs, right? So that means this can be any one of 7 smaller things. This can be any one of 7 bigger things. And then there's the one case, because this number is itself square, where these two things are the same. But if these two things were the same, then b would have to be 0. And you'd have a times a equals this thing. But b can't be 0 because it says positive integer pairs. So we'll scrap that case, and we'll just have the 7 pairs where this is something smaller than this. I don't need to know what any of those things are, but I think the answer will just be that 7. Anyway, that was a really lovely paper, so thank you so much for sending it in, James.